So, hello everyone. My name is Sahil Mulani, and the topic for my presentation is positional encoding. So, let's start. So, firstly, we start with the introduction. In that, why positional encoding is used. Transformers process all words at once, not sequential like in RNN. So, without order information, sentence lost meaning and grammar. Positional encoding provides each word a unique positional identifier. Helps the model understand which word comes first or last, distance between words, sentence structure, and context. I mean to told that the meaning of the positional encoding is that we keep the sequence of the words, just like which words come first. In that, we can see one example. There is one example, dog bites man. If the sequence is changed, if the man is came first, then the meaning is that the man bites dog. So that is the different meaning of the sentence. So that's why the positional encoding is useful and important. So let's see the what is the positional encoding. The positional encoding is a technique used in transformer models to give each word in a sentence positional information. In that there is 4 points. The positional encoding add a positional vector to each word embedding, and it makes the model understand sentence order and encodes relative distance between words. And the works before long sequence in NLP task. The simple idea is that each word is equal to word meaning that is embedded plus word position. There is one example. Uh, there is word like cat at a position 1, a different vector, and word is cat at position 5. That is one of the one different vector. The value of these both vectors are different from each other, and even same words become different based on its position. So let's see how positional encoding works. There are 5 steps in that the positional encoding works. First step is it converts the sentence into tokens, and second is generate embedding for each token. And next is create positional encoding using sine and cosine functions. There are formulas for sine and cosine functions. Fourth one is add embedding to positional encoding to form final input. And last one is transformer process this input to learn the word, order and context. That means that based on that these steps the transformer keeps the sequence of the words which word came first, which word came last. This sequence is kept by transformer, and each step helps the model understand meaning plus position of words. If the same words occur 2 times, it it interpret the meaning of that in correct way. So there is one example: machine learning translation using transformers. Positional encoding helps the model understand words order while translating sequence. So you can see this is the architecture of transformer. So there is two main concepts that is the one is the encoder and the second is the decoder. So the encoder, the job of encoder is to read the entire input all at once. It uses attention function to figure out how all words in the sentence relate to each other. And the second is the decoder. Its job is to write the new sentence one word at a time to keep the sequence of the sentence words. To pick each word, it does 2 steps. One is check its own work, and second is check the reader's notes. Based on that, it gives the sequence of words, challenges, and the limitations of the positional encoding. So it is computational heavy for very long sentence, and it makes hard to interpret how positions are encoded. and the sign cosine patterns may not perfectly match all language rules, and it struggles with very long range word relationship. For example, there is one sentence with 50 plus words it may lose meaning between start and end, even with positional encoding. So, for example, there is a so long word, so it keeps the sequence of last few words, not the first to last. So let's see the summary. So positional encoding helps transformer understand the order of words in a sentence, and it adds positional information to embedding using sign and cosine function. It enables the model to learn context and relationships between words. It is essential for modern NLP tasks like translation, summarization, and chatbots. And it improves language understanding in AI systems like BERT, GPT, and Google Translate. Also, it is the base for the all GPTs and LLMs. So there is one example. It is used in Google Translate for translating and keeping the sequence of words, and it is used to preserve correct grammar and meaning while translating a sentence. So that is all about the positional encoding.